geeks going Gen 8.
In this video, we're going to go ahead and sort of dissect this particular portable repeater, and taking a look at it, reference my hand. It's a medium-sized repeater, nice little old case, just like on our other video. It's got some of the same features. You got your separated transmit antenna here, separated receive antenna there, and then your transmit receive antenna, one antenna with a duplexer. So this is just another design, and this is the power. This is just another design that I could show you, but it's a little bit more simpler than the other examples I showed in that other video. This is something that would really be, you know, a hobbyist modification or something like that. But this was a very good, dependable portable repeater from the early 90s, and it was decommissioned a year ago because of the narrow banding. This radio is not capable of doing narrow banding, so it's surplus now. But I borrowed this so I could show you guys, and we're going to take it apart and see how it works and what makes it work, so you could get an idea of what you would need for your portable repeater. So before I start getting into this particular piece of gear, I want to share this conference call type of deal that I was involved some time ago. Don't even remember when, but I recorded some choice words that was kind of disturbing to me, and one of many reasons why I want my own personal portable repeater. Despite this particular recording, it didn't matter. I was going to do something like this anyway for my use and for my family's use, but this could possibly maybe persuade some of you guys to maybe do something on your own or what have you.
So SB 1160 is basically one of the bills that allows the interruption of cell phone service. So BART, I think a couple of months ago, was able to, in the interest of public safety, shut down cell phone service. This bill basically allows the government entity to interrupt cell phone service in the best interest of the public. And this requires that they get a subpoena or an order from the courts. So that was passed and enrolled, and so now it becomes effective.
To me, that was really disturbing, and the guy was spoken like a true yes man, talking point, politically correct type of individual that wanted to make sure it was for public safety, not for any other reason, though it may be a little percentage of public safety preparedness, but in reality is just covering their asses and keeping the status quo. So a recent political figure was right. Corporations are people. There's some kind of ring of truth to that. Not people like everyday people like you and me, but you know, an organization, whether it be government, municipality, an agency, a department, a corporation, a company, sort of having a self-awareness, kind of like Skylab in the Terminator movies. They get that self-awareness, and they sort of protect their organization by any means possible, and cutting out the cell phones because of a riot or something like that is a tool that was used effectively overseas. You know, what are they going to do so people won't organize? Knock out their communications, keep them guessing. So this series of videos that I'm making about portable repeaters is something to sort of counteract that particular tactic being used against you. It's not foolproof. If they find the frequency, they could jam you. But in my case, this is not for, you know, organizational, what do you call it, subversiveness. This is for an individual preparedness thing, for you to have your own backup infrastructure to have communications when you need it, when things go awry, like in this case. The cell phones go down, activate your portable repeater that you strategically place somewhere, you're good to go. You get in contact with your loved ones and make it out of the area or whatever, and and get out of Dodge. So that's where I'm coming from a self-family preservation type of aspect, not for, you know, a tactic against this, that, or the other. This is a single radio, a single mobile that was modified to do repeater operations. So right now it's configured. I'll just talk right into it. And there it is. 5, 4, 3, 2, 1. And you hear my kickback. So this is another example, another design that is more in line with what everyday garage tinkerers will build on their own. Not a commercially made product, like which this is, but it's more vintage, if you will. So let's take a look at the components. Here you have your control head, and this is where you input multiple frequencies and change channels and all sorts of other things. Here again is your separation of the duplexer from the antenna, bypassing the duplexer. And in this video that I'm going to link, give you a little bit of details. And I'm going into a little bit of details of the duplexer in this unit because a YouTube viewer wanted some more details on it. It was M6PCQ, radio operator from across the pond in the UK. He has pretty good videos on his own, you know, and I really enjoy international viewers out there that PM me about stuff, and I just like to, you know, see their perspective of things and how they handle situation in their particular neck of the woods. It's great. I love it. But anyway, here you have your hand mic, so you can operate this thing here, on and off switch, and this is a programming port, because the only way you could program frequencies into this is to use a PC with the software to run this thing. And so let's take a look at the inside, and there's a unit. This is just a normal speaker for mobiles, and there's the radio box unit, and this is the control head, the back of it, and it's kind of remoted a little bit. Here what you have is two RF switches, sort of relays, and that's what they are, RF relays, which would, the radio output would feed into this and either go out the antenna or go in through the duplexer. So with that switch that you've seen in the front, in the top of the assembly, operates these two relays. This is the receive relay and this is the transmit relay, and all it does is bypass the duplexer. In case you have to operate in frequencies beyond what the duplexer was designed to handle. If I want to use this box for federal frequencies, they usually run up into the 168s and 170s, I have to bypass the duplexer. If this, which is not a ham capable unit, same thing. I will bypass the duplexer because the duplexer cannot handle frequencies below 150, and the ham bands in VHF is around 144, around there. And that again is why we have two separate ports to separate the two antennas. You have the receive antenna and then you have the transmit antenna, separated by distance and elevation, preferably 16 feet. And if you're within the capabilities of the duplexer, of course you're going to use the duplexer and just use one antenna output. So here's the unit out of the box, and all it is these quick release sort of tabs that go in a mounting bracket, and this is the whole unit. It's a little bit thicker than the regular mobile, because in this bottom compartment here is where the duplexer is. And this is the tray, the mounting tray, and it's just a regular old style mounting tray that they used to do back in the day. And this is how it's mounted into the box. Nothing special, nothing custom or anything like that. Pretty much standard stuff. So here they just mounted this on the chassis of the case here, and here's your RF switches that you've seen before. So now we break the radio apart here. This is the actual radio itself, and it's modified to separate the transmit and receive circuitry, and some other modifications, maybe a push-to-talk thing to make it repeat on its own, and maybe rerouting of the audio. I don't know exactly, but I assume that's what's going on there. And then again, here's our infamous duplexer. So this whole unit could run off of one particular antenna, and also to prevent receiver desensitization that will cause a lot of problems with units that are out in the distance. And this one here is miniaturized. The company Sinclair, they've been around for a while, and they're one of the industry leaders in duplexer filter type of equipment there. This particular model is a MR256 star number 2. The star number 2 signifies that it's between 50 and 60 megahertz range. If it was a star 3 or T3 or N3, it would be from 60 to 75 megahertz. Now for you ham guys, if you see this on eBay and it's a -1 or N1 or something 1, MR256, some character and a 1, that is between 136 megahertz to like I think 159. That would be in the ham bands. So that would be the duplexer to get if you're a ham and you want to build your own what do you call it, portable repeater. This will be out of your operating range. Shit hit the fan situation, you want to go covert or you know, break it, the FCC laws or whatever, then what can I say? I'm not going to say anything. I think you know what I'm thinking. Alright, so right now it's configured as built. So let's take a look at the power. Basically 16 watts. 16 watts being transmitted. Now let's bypass the duplexer and see what that power will be after that. So here's the output directly coming out of the power amplifier here, bypassing the duplexer, and it's going to go straight into my test equipment there. Let's see what it reads. Almost 21 watts. So we lose 4 watts coming out of the duplexer. The rule of thumb, what you'll see typically in insertion loss when you have duplexers involved, is a loss of 1/3 the power. That's pretty typical. It'll be nice if it was better than that, and you can get better than that with a properly tuned system. But that is typical. Now for shits and giggles, let's test the receive circuit, see how much losses you'll get with a duplexer having your receive go through. So this is my receive antenna. It's using the duplexer right now. So at this level, 0.37 microvolts, you can hear a little bit of sizzling bacon in the background, and to my ear that sounds about 12 dB cyanide, which is the cutting point between good and bad depending on the levels you put in there. So that is 0.37. Through a duplexer, that is somewhat okay because you have some losses with the duplexer. Now let me bypass the duplexer here. Now let's bypass the duplexer. So I'm going to turn up the volume. Listen to the static in the background while I make the change. Duplexer is off. This is my generator. This is the receive circuit going directly into the radio, bypassing the duplexer. It's a little bit clearer. So right there is 0.22 microvolts, which is a really shit hot receiver for industry specification. So this thing added a little bit of attenuation, but not so much as to make this inoperable. So this is properly tuned, and like I said, you have to pay the piper one way or the other. So here's a duplexer all by itself. It's now hooked up to the radio. On the receiver port, there's your receive range there. And that's like from 157 all the way to around 161.1. That's the range of frequencies that'll be passed through into the receiver. Everything else is going to go filtered out, and here it's just a sheer drop off cliff. But it's going to filter out the transmit frequency, and that's the spike right here, and that's tuned to 151.3. but it's going to filter out a range of frequency around that lower pit right there. And this is your adjustments to this filter here to tune in your duplexer. And I'm just going to move it just a little bit. I'm just tapping it, and you can see how sensitive these freaking adjustments are. So that's another reason why it's kind of impractical to use a duplexer, because you need to tune it. You need high dollar equipment to tune it in there. There's other ways of doing it with radios and other methods, but it's long and tedious. Almost not worth it, in my opinion. If I were to lose my job, this access that I have will be gone, and all I have is, you know, just what everybody else has. For my design, I do not want to depend on a duplexer. So here's the transmit side of the house. Transmit will go in this way, come out the antenna, but blocked from going into your receive circuit this way. And this is the tuning of this particular device. Here I'm receiving around the 151 megahertz there. So I'm looking at 153 to 147, 148, around there. And it's going to reject 159 megahertz around there for the duplex action, because in this particular repeater, the receiver will be in the 159 megahertz and the transmitter will be in the 151 megahertz. You have somewhat of a 8 to 7 megahertz split, where in amateur you have a 600 kilohertz of a split. Very tight. So this device here is not capable of doing the ham bands in that extent. In today's sort of configuration that you see out there, shit hits the fan, you could use 144 receive frequency, and your transmit frequency could be 148. The rules are out the window. So then you could use a device like that has this particular nomenclature, but they do have duplexers that would be able to do that tight separation that you need to filter all that stuff out. But they're really expensive. This is surplus, 148 to 160 megahertz. I seen this on eBay for 90 bucks, but it's impractical for today's rules and laws. And they do have this in the UHF version as well, and the unit would actually be a little bit smaller because of the shorter wavelength of that signal there. So it'll act a bit more efficient than the VHF version of a duplexer. So that is an example of what it takes to build a portable repeater in conventional means, from private industry, businesses and government agencies and municipalities, what they have deployed out in the field. This is pretty much the standard stuff here. But for an individual self-reliance guy, unless you got deep pockets and equipment to maintain all this stuff, this is impractical. This is impractical for me, so I'm not going this route. I'm going to go way simpler than this, not using this at all. But like I said, this is another example of what you see out there and the realities of what it takes to build a portable repeater.